Well, good evening. This is Ahatube, your partner in engineering and mathematics and other academics. Now, today we are going to see the 5 fundamental equations for motions with a constant acceleration. Now, you know most of the equations, but today we are going to see how we derive one equation from the other. So knowing the relationship helps us easily to remember and solve problems of kinematics. Now here we know that acceleration is equal to change in v, change in velocity over change in time. Acceleration is equal to change in velocity over change in time. But this is to mean final velocity minus initial velocity divided by final time minus initial time. But in most cases, we assume the initial time as zero, assuming the initial time, okay, to be zero. Now this equation, acceleration is equal to Vf minus Vi divided by t. If this is zero, Tf is considered as the time elapsed, the time taken for the change in velocity. So from this, we can have now acceleration multiplied by time is equal to change in v, Vf minus Vi. Now taking Vi to the other side, okay, Vf is equal to Vi plus a times t. Acceleration times t is the first fundamental, okay, one of the fundamental equations, numbered as number one. Final velocity is equal to initial velocity plus acceleration multiplied by time. So we do have this formula, starting with the formula acceleration is equal to change in v over change in t. Now, from motion with constant acceleration, we knew that, okay, for motion with constant acceleration, okay, for motion with constant acceleration, okay, acceleration constant, okay, with constant acceleration. Now VAV is equal to VF, okay, minus VI, okay, VF plus VI divided by 2. This is the average velocity. Here, you should remember that for motion with constant acceleration, the instantaneous acceleration and the average acceleration is the same. So this is the second basic formula, the second fundamental equation. This is the second fundamental equation for motion with constant velocity, constant acceleration. VAV is equal to VF plus VI over 2. By definition, we knew that. Okay, by definition, we knew that VAV by definition, okay, by definition, we knew that by definition, VAV, okay, velocity is the rate of change of distance with time, okay. VAV is equal to change in R divided by change in T. For Ti is equal to 0. Now change in R is equal to VAV, okay, VAV times T, okay, times T. Now T, if Ti is 0, now change in T is equal to Tf minus Ti, then now change in T is equal to Tf, which is mostly considered as T. So now change in R is equal to VAV times T. Now this change in R is to mean R final minus R initial, okay, is equal to, and VAV is VF plus velocity final plus velocity initial divided by 2 times T. But we know that, okay, but we knew that but VF is equal to final velocity is equal to initial velocity plus acceleration multiplied by T. Here, from equation 1, VF is equal to VI plus A times T, okay? So, inserting VF here, okay? VF, okay? Inserting this instead of VF gives now VI plus A times T plus VI again, okay? Times T, okay? Times T over 2 is RF minus RI. Now here, we do have 2 VIs, then the sum goes to 2 VI plus A times T multiplied by T, okay, divided by 2 is RF minus RI. Now multiplying every thing in the bracket by T provides 2 times VI, okay, divided by 2 plus, again, A times T squared, okay, A times T squared divided by 2 is RF minus RI, okay, is equal to RF minus RI. Now, this is equal to VI, okay, now this is multiplied by T, sorry, VIT, okay, so it's cancelled, plus 1 over 2 A T squared is the third fundamental equation. VIT plus change in R or change in displacement is equal to V initial multiplied by T plus half AT squared is the third fundamental equation. Now, let's see on the other part. Again, we know that, okay? Again, we knew that, okay? We can use change in R, which we have, let's say, from the definition, okay, change in R is equal to VAV times T. But we knew that. But VAV, average velocity, is equal to final velocity plus initial velocity, okay, divided by 2. VAV is equal to, now this is a bit lighter, okay, VAV is equal to, I will write it again. Now, change in R, okay, is equal to VAV times T. Now it's C. Okay, but VAV, okay, but VAV is equal to VF plus VI divided by 2, average velocity. Then from this, now we are on part 4, okay? Average velocity is VF plus VI over 2, and time is from acceleration is equal to change in V over change in T. Now acceleration is equal to VF minus VI over T for Ti 0. Then time is equal to VF minus VI divided by acceleration. Then we can insert instead of time instead of VAV. So that change in R is equal to VAV is VF plus VI divided by 2 times T is VF minus VI divided by acceleration. Now change in R is equal to VF plus VI over 2 times VF minus VI over acceleration. Now this change in R, okay, change in R is equal to the product of VF plus VI and VF minus VI is VF squared minus VI squared divided by 2A. Okay, VF squared minus VI squared, okay, VI squared divided by 2A is the fourth equation, the fourth fundamental equation. Now from this we can have VI, we can have VF, we can have acceleration, or we can have even the primary representation change in R. Now again this implies, okay, the fourth equation implies, now change in R, change in displacement times 2y's of the acceleration is equal to VF squared minus VI squared. Okay, VF squared minus VI squared. From this, now VF squared, okay, VF squared, velocity squared is equal to 2A times change in R plus initial velocity squared. Okay, this is going to be the fifth fundamental equation. Change in velocity squared, okay, VF squared, okay, is equal to 2 times acceleration multiplied by change in displacement plus initial velocity squared. So this is how the 5 fundamental equations for motion with constant acceleration are being related and derived. Knowing this will help you, okay? You have to repeatedly try to derive these equations so that you will be capable of solving problems that need these equations. So I will add some more example. Now here we have an example. A ball runs at a constant speed of 15 meters per second along a straight line from home to shop, and then returned back along the same straight line at a constant speed of 10 meters per second and reached to the home. Now the first question is, what is the average speed of the boy? And the second one, what is the average velocity of the boy? Now let's put the question in drawing. Now here we have the home, here we have the shop. Okay, the shop. Now the boy travels along a straight line like this, so that we consider the home as one point and the shop as another point. Now the boy has traveled, okay? Now the speed, okay, the boy has traveled from with the speed of 15 meters per second. This is V home shop. Okay, speed from home to shop. And the boy has returned back with the speed of 10 meters per second. Now this is speed from shop to home. Okay, speed from shop to home. Good. So we are supposed to find the average velocity, the average speed of the ball. By definition, okay, by definition, now here we have solution because the givens are here. By definition, we have average speed, V AV is equal to S total divided by T total. Okay? Average speed is total distance traveled divided by total time taken. Total time taken. Now here, we need to think critically. Now the speed of the boy from home to shop is 50 meters per second. And the backward motion, okay, the backward movement of the speed of the backward is 10 meters per second. So that there is a difference between, okay, the time consumed by the boy to go from home to shop and to come back from shop to home. So we do have two types of times, okay, two types of times for the same distance. Then this total distance can be distance 1, distance home to shop, okay, plus the distance from the shop to the home. Okay, this is the total distance divided by now time taken, okay, time taken to travel from home to shop plus, okay, plus the time taken to go back from shop to home. Now, but here we have, okay, distance is equal to V times T. So that from this, time is equal to distance divided by speed. Then this implies time taken, okay, time taken by the boy to travel from home to shop is equal to time taken by the boy to travel or to run from home to shop is S, okay, S home to shop divided by, now the speed here is now V home to shop, okay, V home to shop. Now the speed here, okay, the speed here is 15 meters per second, okay, so that this is distance from home to shop divided by 15 meters per second. 15 meters per second. In the same manner, time required to move from the shop, okay, to home is equal to, again, distance from shop to home divided by 10 meters per second. 10 meters per second. Now, as we can see, the distance from home to shop is the same as the distance from shop to home. So that we can simply put it as S. Okay, we can put it as S. Then T, okay, T home shop is equal to S divided by 15 meters per second. And T shop home is equal to, again, S divided by 10 meters per second, because these distances are the same, okay? The backward and the forward distances are the same. So if we have this, okay, it's easy to solve for the average velocity. Look on the other part. We said that VAV, okay, is equal to S total divided by T total. Now our S total is, okay, home to shop, S, plus shop to home, again S, divided by T home to shop, plus T shop to home. Now we said that this is 2S, okay, 2 times S divided by T home to shop. Home to shop is now distance divided by 15 meters per second, plus, now this time is distance divided by 10 meter per second. 10 meter per second. Now this is equal to 2 times s divided by, now the LCM of the two is 30. 30 divided by 15 is 2 times. 2 times s is 2 times s, plus 30 divided by 10 is 3 times. 3 times s is 3s. Okay? Now this is equal to, now this is equal to 2s divided by 5 over 10s. Now s can be cancelled out. Okay? So this is equal to 2 divided by 2 times. Okay, this is to mean 2 divided by 5 over 10, which is equivalent to 2 times this is 30. Okay, 2 times this is 30. Okay, this is 30 above, sorry, yeah, this is 5 divided by 30. Okay, so this is 2 times 30 divided by 5. Now by 5, 1 times, by 5, 6 times. So this average speed of the boy is 2 times 6 is 12 meter per second. 12 meter per second. This is the average speed of the boy for the entire trip. Okay, what is the average velocity of the boy? B. Now this is for question number 1. Okay, let's see for number 2. Now number 2, question number 2 says, what is the average velocity of the boy? Now number 2, the average velocity, okay, the average velocity of the boy is equal to the total displacement divided by changing t. But looking the question again, now a boy runs at a constant speed of 50 meters per second along a straight line from home to shop, and then returned back along the same straight line at a constant speed of 10 meters per second and reached to the home. Okay, this is to mean, okay, the boy started from this point, ran with the speed of 50 meters per second, reached the shop, and returned back with the speed of 10 meters per second and reach the point he started back. Okay, the point he started. So that if the boy come back to home, its total displacement is zero, because he's in the same place where he started his motion. 0 meter divided by any time t, okay, changing t, is equal to 0. Okay, meter per second. Okay, 0 meter per second is the average velocity of the boy. This is Ahatube, okay, Ahatube, your partner in engineering, mathematics and physics courses. So do not forget to like, do not forget to share, and do not forget to subscribe on our tube so that we will work more. Thank you for watching, and see you on the other videos.